In an earlier lesson, I've explained that every single programming instruction itself has an address in memory. For example, consider this. Now, every instruction in Figure A actually will have its own memory address where that instruction lives. Therefore, to execute these instructions, your CPU must first point the instruction pointer to the line that says int height equals 5, and then the if statement, and so on. Now, the way this actually works in machine code is a bit more complex, so keep in mind that what I'm describing is for illustrative purposes. What you may be wondering at this point is, what exactly are these braces all about? The answer is that these brace characters, which I've explained before, define the start and end of a block of code. More specifically, they define the memory address that will be at the start of the block of code and the memory address that will be at the end of the block of code in your final program. In other words, they are equivalent to the GOTO labels that we saw in the previous lesson. Now consider this code. Now here we have an if statement where we're defining a block of code. So this first brace corresponds to a specific memory address where the block of code begins, and the second brace is where the block specifically ends. Now what I've done here is I've replaced the braces with labels. Now don't consider this as valid C code, it's just for illustrative purposes, but what I want you to understand is each label, start of code and end of code, can be thought of as a memory address. And now we can take this one level deeper, and now we can see more or less what is happening at the machine code level. We're comparing height to 5, we're checking the 0 flag, and if the 0 flag is on, then we want to jump to start of code and execute what is in here, and if the 0 flag is 0, then we want to just jump to end of code, which has the effect of jumping over this. And as you recall from the last lesson, the way that we do that specifically is we set the instruction pointer to either this memory address or this memory address. Now, in truth, this is redundant because we don't need this third instruction, because if height is equal to 5, we don't need to tell our program to jump to start of code because that's the very next instruction anyways. So we can effectively remove that instruction, and all we really need to do is say that if height is not equal to 5, then we want to jump here. So keep in mind that when you're looking at a block of code as defined by an opening and a closing brace, what you're really talking about are two memory addresses, one where the block of code begins and one where the block of code ends. And the conditional statements use these braces as the specific part of the program they are going to jump to in order to define which instructions to execute. Now, not all programming languages use braces as the way to define a block of code. Some programming languages use indents. So for example, this is Python, how Python would have a block of code. You basically would have your conditional statement here, and then your block of code is simply indented, and then you go back to non-indented code once you leave the block of code. So in Python, effectively what's happening is that these braces are understood as being at the start and end of the block of code, but you don't actually place the braces. Indenting is enough. That's just an example of how another programming language does it. What I want you to understand is that there are many different ways that a programming language might do something, but once you understand the concepts, you can take that knowledge to any programming language you want. And once you understand, oh, this is what a block of code is, then you can pick up a book on Python and start seeing how to write Python code, just understanding that now this is how Python makes blocks of code, or this is how Python does a conditional statement. No programming language can do something that another programming language cannot. All are limited to the machine code instructions your CPU can execute. Once you learn how to program in C or in any other language, you can take that understanding and learn any language you wish. Throughout this course, we will look at the various ways that these same operations and concepts can be implemented in a wide variety of languages. Right, so that concludes this lesson.